We are with 2015 Calculus A, B, and BC question number 4. So I already did some pre-work for you. So we're given 6 points and we're asked to draw the slope field. So basically we draw a little line segment with the slope that the curve has at that point. To find the slope, use the derivative because the derivative tells you the slope of the tangent line. So as you see on all the work I've done there, I plugged in the coordinates into the dy dx differential equation and I found the slopes. So when you draw these, I'll give you a few notes here. You don't have to have perfect slopes, but like the slopes of 1. Take a look at this one and this one. They have to have a slope of 1. So if you kind of look at your rise and run, if they're about the same, you're good. The slope's about 1. So that's pretty straightforward. This one here, the slope's -1. So if your rise and your run are about the same, you're good. But how do you get the -2? It just has to be steeper. This is -2. It has to be steeper than this one. And if you look, it's not perfect, but it is steeper. You might want to make it a little steeper than that, but clearly the rise is greater than the run. It probably needs to be a little steeper. The only reason I'm reluctant to do that is because I have a slope of 3 coming up, but you could make it a little steeper. That's probably a little more accurate to a slope of 2. Yeah, that rise looks like about 2 compared to that run. And then the slope of 3, that one's a little tricky, but that might be a slope of 3, but it needs to be steeper than the slope of 2. They're not going to get a ruler and measure it out. They're just looking for a steep slope, steeper than this, and this 2 has to be steeper than the 1. So that's all that's going on there. That's all worth 2 points for all that. Pretty easy 2 points. Part B. They want the second derivative. So we have the first derivative. I already wrote it here for you. Let me do this. Now, here is the thing you have to be careful. X is your derivative. Y is a function. So when you take the derivative, that's x. You take the derivative like normal because that's an x. But that, when you take the derivative of that, that is a function. So you have to treat it as a function. So let's take the derivative. The left side will be the second derivative, clearly. The derivative of 2x is just 2. But what is the derivative of y? The derivative of y is dy dx, which is the derivative of y. So they want it in terms, if we look, of x and y. So we need to get rid of the dy dx. Don't forget the parentheses. So we'll get 2 minus 2x plus y when we distribute that. Now the next part of the question asks for the concavity in quadrant 2. Is it concave up or concave down? We should know the second derivative tells us that. So what's true in the second quadrant that will tell us the sign of the second derivative? Well, what do you know about x in the second quadrant? X is negative. So in quadrant 2, x is negative, and in quadrant 2, y is positive. So look, if you were to put a negative here for x, a negative times a negative would make a positive. This will always be positive in the second quadrant. Y is always positive. Therefore, the second derivative is always positive in quad 2. Therefore, and let's get the wording, solution curves. What do you know about all solution curves? Therefore, all solution curves, that's not an L, curves in, I don't know how to do capital Q in script. That's sad. I think I do, but it's weird, and I don't want to mess up. In quadrant 2, R concave up. Let's go to part C. Now, let's look at this. This is a particular solution. So I remember this year, a lot of people tried to find the solution by using separation of variables. It's not asking you to find the particular solution. They're telling you y equals f of x is a particular solution that goes through the point 2, 3. So they're telling you that there is a solution, and let's assume y equals fx is that solution. Then it's asking, does f have a relative minimum, a relative maximum, or neither? So first of all, you have to make sure that at 2 there's a critical point. So let's make sure there's a critical point. So let's find dy dx at the point 2, 3, and that will be 2 times 2 minus 3, which is negative 1. Since the derivative is not 0, therefore it's not going to be a relative max or relative min, because they can only occur at critical points. So let's do this, give an answer to that. So part C, since dy dx at the point 2, 3 does not equal 0, therefore f has neither a rel max or rel min at x equals 2. And that's it. So that one's kind of weird. It's actually easier than it looks, because people just, I don't know, for some reason they think, find the solution. So part D, again, they're not asking for a solution. They're telling you y equals mx plus b is the solution. They're giving you the solution. But they just want to know what m and b are. So what is the solution? This, again, a lot of students struggle on this one. What is a solution? We have dy dx equals 2x minus y that's given. You should just know if something is a solution, that means if you plug it into your original equation, it must work. If it works, then it is a solution. So if you look at our original equation, there's our y. So what are we going to do? We're going to plug this in for y, because that's what it means for something to be a solution. But for this, we need to plug something in. So what we have to do first is find the derivative, dy dx, and that's just m. So now knowing that, we're going to plug m right here, because again, that's what it means to be a solution. You plug it in. So let's do that and see what happens. M is 2x minus y. So here's what's happening. These are constants. So if those are the only constants, they have to equal each other. Now, invisibly, there's x on the left side. We just don't put it because it's 0. So you have a x term and a constant. For the left side to equal the right side, both those must be equal to each other. So 0x must be equal to 2x, and m must be equal to minus y. All right. My brain just went blank. What am I doing here? Oh, let me back up a little bit. I just realized I never replaced y. What a lame-o I am. I was like, why isn't this working out? I don't understand it. Sorry, everybody. I never replaced y. Y dies out. Okay, I get 2x minus mx minus b. Okay, everything's looking a lot better. So on the left side, I have an x term and a constant. On the right side, I'm going to factor the x out. I have an x term and a constant. Now we're talking. The coefficient x here must equal the coefficient x here for those to be equal to each other. And the constant here must be equal to the constant here. That must be true. So we have 0 equals 2 minus m equals 2. And we have m equal the opposite of b. Well, to solve for b, m is 2, b is negative 2. We found the m and b. You see, we are done. Yes, we're done. All right, that's it. Off to number 5.